Today's learning goal is to draw vectors in 2 dimensions. Draw vectors in 2 dimensions. Okay, so we're going to start off today's lesson with a little bit of review. Scalars, if you remember, the difference between a scalar and a vector is that scalars are characterized by magnitude, so they're basically just a number, whereas vectors are characterized by magnitude and a direction. So quantities that are scalars would be things like the number of people in a room, or things like temperature, mass, time is also a scalar. Vectors have a direction associated with them. So for example, forces, we haven't talked about forces yet, but a force is essentially a push or a pull. And forces, if you think about it, you push or you pull with a certain strength, but you also push and pull in a particular direction. Velocities are vectors, so how fast an object is moving and in which direction the object is moving. Accelerations are vectors, how quickly the velocity is changing and in which direction it's changing. The displacement of an object is also a vector quantity. So displacement is how far an object moved from its initial position and in which direction it moved. Okay, so in physics, we're very interested in this idea of vectors. There's lots of different quantities, physical quantities that can be represented as vectors. So one representation of a vector, right, the vector itself is just an idea in our mind, but we can represent the idea of a vector using an arrow. So we could draw an arrow on our paper, and notice the arrow has a particular length. So this is the magnitude, represented as the length of the arrow. And then also the arrow points in a particular direction. So if we want to specify which direction the arrow is pointing, we're going to need a frame of reference. So this could be like x and y, for example. And then we could say, okay, the arrow is pointing at a certain angle with respect to the x direction, for example. Okay, so let's look at a few examples of this to practice drawing some vectors in 2 dimensions. Okay, the first example that I want to look at is the vector 20 kilometers due west. 20 kilometers due west. So first things first, let's go ahead and write down the coordinate, the reference frame on our paper. So here we have north and east, and then if you remember, south points opposite of north, so down on our page, and then east points opposite, west points opposite of east, so west points in this direction on our page, so towards the left on our page. Okay, so this is west, in this, right, this way is west, and this way is south. Okay, so 20 kilometers due west, we have to draw our vector. Let's say this vector has a magnitude of 20 kilometers, and we're pointing our vector in the west direction, so 20 kilometers due west. Okay, let's try another one. So you try this one, 7 meters per second. Go ahead and draw the vector 7 meters per second, directed southeast. So pause the video now, draw the vector 7 meters per second southeast. Okay, so let's go ahead and draw the coordinates so that we have a frame of reference. Traditionally, right, let's draw north pointing up on our page, east pointing towards the right, and we're being asked to draw a vector 7 meters per second pointing towards the southeast. So south is down on our paper, opposite of north, and then southeast is going to be exactly in between south and east. So we should draw our vector like this, with a magnitude of 7 meters per second. and it's going to be at a 45-degree angle to the east direction, or a 45-degree angle to the south direction. Okay, let's try another one. So this, I want to draw a vector that's 12 newtons. Newtons are the unit of force. So 12 newtons at 32 degrees east of north. So pause the video now, draw the vector 12 newtons at 32 degrees east of north. Okay, let's take a look at the solution. So again, we're dealing with east and north, so let's go ahead and draw our frame of reference. Here we've got the north coordinate. Pointing this way, and then we've got east pointing to the right on our page, and south will point down, and west will point towards the left. And then, so we've got northeast, east of north, 32 degrees east of north. So we need to try to think about what does that mean, 32 degrees east of north. So if north is pointing this way, 32 degrees east of north, we have to go 32 degrees towards the east with north as our reference. So starting from north, 32 degrees east of north is going to point like that. So let's go ahead and draw that. So the north direction pointing like this, and 32 degrees east of north will be something like that. 32 degrees, and then the magnitude of our vector is 12 newtons. Let's try another one. So let's try 22 meters per second at 45 degrees left of forward. So go ahead and draw the vector 22 meters per second at 45 degrees left of forward. Pause the video now. All right, let's take a look at your solution. So forward, we have to decide where we're going to draw forward on our paper. I think forward makes sense to draw forward in this direction, assuming that we're like sitting in front of our piece of paper. So we'll make the forward direction kind of like forward to how we're sitting in front of our piece of paper. And then left is pointing this way, right is pointing this way. So this is right, and left is opposite of right. And then this would be back. If that's forward, this is backwards. Okay, so we want 22 meters per second at 45 degrees left of forward. So forward is our reference, and so forward is this way, and then 45 degrees left of forward will be left of forward. So 45 degrees, and we're going to start measuring our angle 45 degrees with respect to the forward direction. So our forward direction is along this line, and then left of forward will be measured in this direction. So something like this. And then 22 meters per second is our magnitude, so 22 meters per second at 45 degrees left of forward. Okay, let's try one last one. I want to do 7 meters. We're going to draw the vector 7 meters at 120 degrees clockwise from the negative y direction. Pause the video now, try to draw this vector 7 meters at 120 degrees clockwise from the negative y direction. Okay, let's take a look at how you did. So the y direction points that way, the x direction points towards the right, so negative y points opposite of positive y. Right, this is negative y. Okay, and clockwise, we have to remember which way the hands of the clock turn. So clockwise is like this. So let me draw a little sort of circular arrow to remind myself which way clocks turn. Something like that. So 120 degrees clockwise from negative y. So let's begin with negative y. That's where we're going to start measuring our angle. Negative y points along this dotted line. And then we're going to be measuring 120 degrees clockwise. So to get to 120 degrees, I have to go past 90 and then not quite all the way to 180, right? So 120 is going to be somewhere around here. And we're going to be measuring that with respect to the negative y direction. So we start measuring from negative y, and we have to go clockwise 120 degrees. And the magnitude of our vector is 7 meters. All right, great job. That's our last example.